Hello, everybody. It's really great to have this opportunity to introduce to the world NylaNova, a company that is dedicated to tackle the most challenging yet most abundant plastic waste streams, which are mixed plastic waste. My name is Yossi Kratish. I'm the founder of NylaNova. I'm also a research assistant professor at Northwestern University, where I'm proud to say that in the last 6 years that I'm here, I was able to develop new advanced recycling solutions for all the most popular plastics out there, spanning from polyolefins, polyesters, polyurethanes like spandex, and the star of the show today, polyamides, which include nylon 6. I'm really grateful for the grant we received from Apparel Impact Institute, which will really enable us to accelerate what we plan to do. And today I will tell you what we plan to do. So NylaNova is a fairly new startup. We incorporated last year, and we plan to advance the technologies that we developed at Northwestern for the last couple of years that enable a cost-effective chemical recycling way of converting difficult to recycle plastic into valuable products. We are doing this by harnessing the power of catalysis, which allows us to really save energy intake, reduce the temperature, and make the reaction overall significantly faster than what's currently on the market. We also have a very strong executive team that comes with a rich background of commercializing technologies, R&D, and a lot of experience in nylon manufacturing, fiber production, and their recycling. And the problem that we are addressing is a global concern, which we don't know what to do with all the plastic waste that we are producing. 90% of plastic today globally is being landfilled or even worse, incinerated. This results in huge economic losses because we are landfilling or burning really valuable material. A lot of the plastics that we use are single use. So we use it once, maybe twice, and we throw them away. And it's just a bad practice and we need a solution. Now, everybody wants to recycle, and we are recycling, or at least we think so. Globally, 9% of plastic is recycled, and in the US, it's even worse. It's less than 5%. And what we call recycling today is essentially a mechanical recycling approach, where we take waste, we clean it, we sort it, and we melt it. And what do we get? We get old, molten, recycled plastic. It can never really achieve the same properties as virgin. And it is very limited to a very narrow type of plastic, which is really clean, pure waste, which is very challenging to get. What we do need is a true solution that could enable a circular economy in which every bottle can be converted back to the same bottle, every shirt could be back to the same shirt. So we need a new technology, and this is where we come in. Now, traditionally, all plastic today is made from fossil feedstocks, right? We work really hard to remove it from the ground and convert it into monomers. Those monomers are then polymerized and assemble our products. A lot of the clothes we wear today are made from plastic, essentially. Those include nylons, like polyamides and polyesters. After we finish using those clothes, the majority of us will throw them away. And this is what's happening today with the majority of textiles. Less than 1% is being recycled today. Well, this is where NylaNova comes and closes the loop with our infinity recycling approach, in which we can take all clothes or plastic products, add our proprietary catalyst, and depolymerize those materials back into the starting monomers. And the advantage is that those monomers have the same quality as the ones that are made from petroleum. So essentially, we can always continue this loop: polymerize, use, recycle. The advantage of our process is it is really low cost. Our preliminary technical economical analysis suggests that we can produce the monomers at a lower cost than virgin, making this really attractive to a lot of manufacturers. We use the most green solvent in the world. which is no solvent at all. We don't use, all we need to have is our plastic waste and our catalyst. And that's it. And it is compatible, and we tested that with post-consumer waste. So those wastes are challenging because they have other contaminations like additives, other types of plastics. It doesn't hurt our process. It is very selective, only to the plastic that we want to depolymerize. We have in our portfolio 5 patents that are covering nylon 6 depolymerization, as well as polyesters such as PET. So the first project, and this is what we will be doing with this grant, we will focus on nylon 6 apparel. Transitionally, and this is a free chemistry lesson, nylon 6 is produced exclusively from caprolactam, this cyclic molecule that you can see here. If you have this one, you can heat it under a certain condition, it will ring open, and it will attack itself. And you will do it enough time, you're going to generate a very linear and long nylon 6 polymer. You can spin fiber out of it and use it for a variety of applications. It has a fairly big market. It is a really useful polymer. It's very resistant. It's lightweight, and very hard to degrade. This is why it is used today. Well, we can do exactly the reverse. So instead of a traditional route, when we have a 6 or more steps from fossil feedstock to caprolactam, we can take waste, and in one single step, we can get the same caprolactam. Here's an example where we took end-of-life textiles. Those are tricky to recycle. Today, they are considered non-recyclable. It has a mixture of nylon 6 and spandex to make them stretchy. It has color inside of them. We add our catalyst, we melt it, and you can see here a video of the caprolactam that we are collecting. You can see color-free, really pure caprolactam, ready to be used further. When we remove the caprolactam from the flask, it is solid at room temperature. You can see this nice white powder that came from this waste fabric. So where we are today. Today we are located, majority of work is done at Northwestern University in our lab. We are small. From the science, from the amount of people that are developing the science, we have only one, which is currently it's me. And the prototype I built is currently can process around 0.5 kilogram of waste. It's clear that there is a lot of interest from the industry, and we need to accelerate our progress. And this is why it's really great to have the funding from Apparel Impact Institute, because our plan now is to do what we wanted for a while, which is to move out to our own space, hire additional staff that could work on those problems that we have. We reached to a point that partners that are working with us, they saw the technology works. They now want to get samples to test it in their facilities. So this new equipment that we plan to purchase will allow us to generate those samples. And we aim around 10 kilograms per day. This will allow us to generate enough material to share. As we're moving forward, we're gonna test different types of textiles. Those could be some that have 5% spandex and some that have 20. There are nylon 6 fabrics that have PET inside of them and other materials inside. So we need to really expand our scope and to see how much of the textile waste we can capture. And then we will have enough caprolactam. We will need to do something which people are doing for since nylon was invented. We need to polymerize it and spin fiber out of it. Once we achieve those milestones, we're going to reassess our techno-economical analysis and the life cycle assessment just to see the impact of our technology on this field. Achieving those milestones will really enable us to reach to the next stage, which will also help in fundraising, which is start commencing a pilot plant that can process a ton a day. This is the first step before you're going to a commercial plant. This is exactly the time to tweak the process again and really understand how everything is working. So we plan that in 2028, we're going to start a massive production of recycled caprolactam. that will be used to generate nylon 6 fiber. So the goals and the things we want to learn from during the next year, high level, are we want to scale up and we want to see what happens when we scale up our technology. We want to ensure that we have enough different types of fabrics that you can process and generate clean caprolactam. We have to ensure that our product is fiber grade. So as we're gonna test different kinds of fabrics, we will see what we get, and we're gonna refine our technology accordingly. And then the fun part, we're gonna polymerize it and spin fiber. And again, assess the impact and the economics of it once we get this additional data. If we're breaking down kind of to different tasks and milestones that we need to accomplish, in the first half a year, we will be scaling up, optimizing our process, and testing fabrics from our partners that has been delivered to us. And then we're gonna, in quarter number 3, we're gonna start shipping out samples. And ideally, there's a good feedback, and we will start polymerize nylon 6 with external partners and spin fiber. Those are well-mature technologies, so our goal is to have a drop in caprolactam, and so far it looks exactly that this is what we will enable to do. Now, I mentioned the huge problem that we have with the waste that we need to landfill, but obviously there is another huge global concern is the fact that the plastic industry is responsible for more than 5% of carbon emissions globally. At 2019, more than 2 billion tons, metric tons, were produced just due to plastic production. And this is expected to triple in the next 30 years. We will not stop using plastic. So we need to be responsible in how we are dealing with the waste that we are producing. So if we can produce plastic using an alternative, more green approach, we definitely want to do that. And this is what NylaNova wants to bring to the table. Our preliminary assessment suggests that we can cut emissions by 80% if we use waste to fabrics as opposed to fossil feedstocks to fabrics or apparel. So by a massive and global deployment, we could really cut the carbon emissions by a lot. So NylaNova is working on several polymers. Nylon 6 is the one that is the most mature, and it's working pretty well. So we really want to scale it and achieve a commercial scale. This is not the only polymer that we will have, and soon, hopefully, we could report about the success of other ones. But I really invite you to come and talk with us. If you have waste that you're producing and you're concerned how to deal with that, please contact us. We'll be happy to talk. Thank you.